A drill bit is used to create holes in a variety of materials. A countersink is a tapered hole drilled with a wide outer portion the same diameter as the intended screw head. A plug cutter removes a round piece of wood with which you plug the hole afterwards to hide the sunken screw. Kinda twisted logic. Countersinks and plug cutters start out as steel bars. To make a countersink, this computer-guided tooling machine uses a center drill to pierce a starting hole, then switches to its main drill, which bores right through. Next, it uses what's called a rough turning tool to shape the countersink's angled nose, then its body. The machine now switches to a milling cutter. This tool shapes the countersink's 4 blades. A cross-drilling tool bores a hole for the 2 screws that'll hold the countersink to the drill. A tap cuts threads into the hole. Next, a tool called a dovetail cutter sharpens the blades. Then finally, a cut-off blade removes the tool. The same machine makes plug cutters. Its center drill makes a starting hole, but this time, the main drill doesn't bore right through. It stops at the depth that the plug cutter is designed to cut. Just as before, the rough turning tool shapes the body, and the milling cutter sculpts the 4 blades. After the dovetail cutter sharpens the blades, a tool called a boring bar refines the hole in the center, making it the proper size. Another turning tool now forms the shank, the stem of the plug cutter that you insert into the power tool. Then the cut-off blade slices the tool off. Now for some manual touch-ups. First, they grind the plug cutter against an abrasive wheel to remove excess metal from the cut-off. Then the sides of each blade are ground to a particular shape that'll clear the wood chips. Here's how the plug cutter looks before and after grinding off the excess. And before and after side chipping. And now for making the drills to which the countersinks attach. It all starts with a tapered piece of steel, because this will become a taper point drill. Straight drills begin with a straight piece. A mechanical arm inserts this drill blank into a computer-guided grinder. The machine has 2 wheels made of boron nitride granules, a natural mineral that's tough and abrasive. The first wheel shapes the smooth blank into lengthwise spirals called flutes. A second wheel then grinds sharp cutting edges on the flutes and shapes the tip of the drill to a point. Back to the countersinks now. The steel is still relatively malleable, so a worker runs each one through a stamping machine that imprints the size of the tool and the company name. Countersinks and plug cutters must undergo a heat-treating process to harden them. 20 minutes in a fiery oven with a secret recipe of chemicals. The intense heat, 955 degrees Celsius, transforms those chemicals into gases, which then permeate and harden the steel. After cooling in warm water and oil for about 15 minutes, workers submerge the tools in an industrial-strength cleaning solution that removes all the grit. Then a bath in acid removes any soot. Finally, 20 minutes in a blackening solution, the ingredients of which are again a closely guarded company secret. This last step is purely cosmetic. Here's how the 3 drill bits work together. First, you use the plug cutter to make the plug. Then you pop out the plug with a screwdriver. Next, mounting the countersink, that black tool onto the taper point drill. You drill a hole for the new screw. Then you drive the screw into the hole, sinking it below the surface. Then you cap the hole with the plug. These tools come in an extensive range of sizes and grades for both amateur and professional woodworkers, and for industrial machines. Who said DIY was boring?
never slow up, no I don't take shit, I got no love